Good afternoon to all of you. If my voice is audible,
Yes, sir.
Yes.
just scan this QR code for the attendance. Wait for a minute, then we continue our class. Yes, I think all of you have given the attendance. So shall we start?
Yes, sir.
Okay. So just let me recall what we have done yesterday. So कल हम लोगों ने दो चीज सीखा था. First, what we have done now, if the number of bit is given, okay, if the number of bit is given, suppose for address location, okay, for the address location, if I am using 10 bit, okay, if I am using 10 bit, then what is the total number of location possible? What is the total number of location possible?
2 to the power n.
2 to the power of n location is possible. Okay, if I'm using 10 bit for addressing, then 2 to the power n location are possible. And if I'm saying, okay, each of my location is byte addressable. Okay, or each of this. Now suppose that means if n bits are there, if this is my memory. Okay, तो हम लोग कितना लोकेशन कर सकते हैं, क्वेश्चन मतलब डिफरेंट लोकेशन को एड्रेस कर सकते हैं. Okay, it will be 2 to the power of 1. If I start with 0, the first deposit start with 0. Now the last location will be power of n minus 1. Total कितना हो जाएगा? Total will be 2 to the power. Now if it is byte addressable, 1 byte addressable. Now if I'm saying each of this one is 1 byte addressable. Okay, and total memory will be how much? Total memory will be 2 to the power of n into 1 byte. Now if it is 2 byte, okay, as in this 2 byte addressable, then it will be 2 to the power of into 2 byte. So this much memory, okay, if this number of bits are given, this much memories are possible. Yeah, so we have learned. The second thing what we have learned, if memory is given, if total memory is given, if I'm saying this is my memory, okay, now suppose memory of 64 KB is given. So can I find this address? Sorry, can I find this number of bits? Yes, I can find. So the formula is total memory. Okay, formula क्या था? Total memory is equal to what? Is equal to n into addressable, whether it's byte addressable or any other. Suppose it is byte addressable, so it is 1 byte. So from which we can calculate what is the value of n. That means हमने दो चीजें सीखे थे हम लोगों ने. If n is given, number of bit is given, now I can find the total memory. Okay, total memory. Or if total memory is given, we can find the number of bit required. Okay, then we have discussed one example. Okay, where this concept is applied. Basically, this concept is applied in terms of page. Okay, in terms of paging. Yes or no? We have discussed one example yesterday. Remember that example? Remember that example that we have discussed yesterday? Yes? Yes or no?
Yes, sir.
Clear to all of you? So let me take another example of same type. Okay, that it will be further clarified to you. So, so what we know, the CPU is always generating the logical address. Okay, so carefully listen. So this is my logical address and we know that the logical address consists of two fields. One is your page, okay, page number, and second is your offset address.
Offset.
Fine, so this is offset address. Similarly, if I say the physical address, if I say the physical address, now this physical address consists of two things, which is equivalent. Now this logical address relevant to what किससे एसोसिएट होता है सेकेंडरी मेमोरी से. Now physical address जो है किसके साथ एसोसिएट होता है आपका प्राइमरी मेमोरी से. Now this physical address consists of two things. One is called frame, ठीक है? One is called frame, and this is offset address. Okay. Now this D is same for both the cases. Now this is offset address, which will be calculated with the help of page size. Now what is given in the question? The question में था आपका logical address is given. The logical address is using 33 bit. Now your logical address is using 33 bit for address representation. Now your physical address is given, which is using your 24 bit. Okay, and the page size is given. Page size is given. Okay, page size is 2 KB. Okay, always remember एक चीज यहाँ पे आता page size से हम लोग number of bit used for the offset address can be calculated. Okay, page size से क्योंकि page size क्या होता है आपका मैं secondary memory का एक page लेंगे. Now this is your page size. This is nothing but your D. This entire thing is your D, which will be same. Okay. Now page size is 2 KB. Can I calculate the number of bit? Now this 2 KB is given. This is peak KB. Okay. 2 KB is given. So can I calculate how many bit is used for this page KB? Yes. If the memory is given, I can calculate. So do remember what is the significance of page size? Now from the page size, I can easily calculate. If the page size is given, I can calculate what is the number of digit that is used to calculate the that is used for the offset address. Fine. Fine. It is clear to all of you. Is it clear to all of you? So now what is given? The logical address. How many bits are used? Now logical address is using 33 bits. Now entire this address it is that I can say that P plus D. So your P plus D is how many bits? P plus D is your 33 bits. Fine. Similarly, आपका physical address कितना दिया हुआ कितना bit use कर रहा है? 24 bit. Physical address is using 24 bit. So can I write F plus D? F plus D is your how many bit? 24 bit. Okay. Now tell me with this 33 bit, what will the memory size supported? What will be the memory size? What will be the memory size? With this 33 bit, if I am using 33 per address location, then what will be the memory location? Now assume that my system is byte addressable. Okay, the system is byte addressable. Okay, the system is byte addressable. Yes, what is the memory? What is total memory supported with this 33 bit?
8 GB.
It will be something around. It will be 2 to the power of 33 into 1 byte. So I can further divide this one as 2 to the power of 3 into 2 to the power of 30 into 1 byte. And we know that this 2 to the power of 30 is nothing but GB. So it will be equivalent to somewhere around 2 to the power of 8 is 8. Okay, now this is GB. Okay, 30 is GB. Now the memory supported will be 8 GB. That means your secondary memory up to कब तक सपोर्ट कर सकता है 8 GB तक सपोर्ट कर सकता है अगर वो बाइट एड्रेसेबल है. And total number of location will be it will be 2 see location, different location is possible. Similarly, if physical address is 24 bit, then what will be the memory size that is supported? What will be the memory size it will support it?
Sir, 16 MB.
It will be 16 MB. It is very simple. It will be 2 to the power of 24. That is byte divisible, so 1 byte. I can write this 2 to the power of 4 into 2 to the power of 20 into 1 byte. Now this is 16, and as we know, 2 to the power of 20 is MB, so it will be 16 MB. Okay, so my memory size maximum क्या हो सकता है 16 MB और अंदर का जो सेकेंडरी मेमोरी उसका साइज हो सकता है 8 GB. Fine. Now what is given? Next, what is given? Now the page size is given. Now what is given? Now I have given the page size. How much the page size is? Page size is 2 KB. Okay, 2 KB. The page size is 2 KB. Okay, each of these page. Suppose this is my secondary memory. I say, और secondary memory क्या होता है? Divided into terms of pages, है कि नहीं? Now each of these page sizes 2 KB. Okay, and I know that this is particularly the offset address. This particular differ, the page size refers the offset address. So what we can do now, I know that total memory, okay, for the page size. Now same formula I will use total memory. Okay, total memory is equal to, we know that 2 to the power n into, now it is not divisible, so it is 1b. Fine. What is total memory is given? Total memory is 2 KB. Okay, this is 2 KB. This is 2 to the power of n. Okay, n into 1. So I can write this one 2 to the power of n equal to, now this 2 KB can be written as 2 to the power of 2 into 2 to the power of 10 byte. Yes or no? Can I write this one? This KB can be written like this. Yes or no? लिख सकते हैं. Okay, now this byte goes cancel. Now this 2 to the power of n equal to कितना हो गया? It is 2 to the power of 11. So what is the value of n? What will the value of n? So n will be equal to 11. Now ये जो n है याद रखना, ये जो n है that is not nothing but equal to d. This is nothing but equal to d. Why it is d? Because we are calculating the value of n from the page size. अगर पेज साइज से हम लोग n का वैल्यू निकालेंगे, वो आपको रिप्रेजेंट करेगा what will be the maximum number of digit used for the offset address. Now what is the value of n? N equal to what? N equal to 11. Now I can write, now this n equal to 11 and this, sorry, d equal to 11 and this equal to 11. Now you tell me, if d equal to 11, so what is the one? How many bits are used for f? If d total, how many f plus d is 24, f plus d कितना था 24. Now what we calculated from the page size? From the page size we have calculated the value of d, which is equal to 11. Yes or no? From the page size I have calculated the value of d, which is equal to 11. Then what will be the value of f here?
13.
It will be 24 minus 11. This will be 13. Is it clear to all of you? Now I am finding the f value. Okay. Now similarly, tell me if 11 is used for the offset address, then what will be the value of p here? What will be the
22.
It will be 22. So let us understand what is the significance of this. So as we know, with p represents pages, this p represents number of pages, then how many locations are possible in secondary memory? The total number of location, total number of pages or pages you can say, or location you can say, total number of pages or location you can say, or let me write the pages. Total number of pages possible in secondary memory is, it will be 2 to the power of 22. Okay, 2 to the power of 22 possible pages are available. Okay, similarly, what is total number of frames? What are total number of frames that will be available in primary memory? Total number of frames are is equal to 2 to the power of 30. Okay, this much possible. जब आप मेन मेमोरी बनाओगे तो कितने फ्रेम्स होंगे आपके पास? Now how many frames are possible with this example? How many frames are possible? It will something start from 0. Now it will end 2 to the power of 30 minus 1. Now it will be 1, 0, 1, yes, 0, 1, 2, like that. And size of each of this frame is equal to what? 2 kb, because the frame size is equal to page size. Okay, this is my main. Fine. Similarly, what is secondary memory? Now your secondary memory will consist of frame. Okay. Now divided into pages. Now this will be equal to pages. Now how many pages are possible? Now if we start from 0, total number of pages are possible 2 to the power of 22 minus 1. Okay, like this 1, 2, continue to minus 1. And each of these pages is equal to size of 2. Now how easier now you can see here. Now suppose I will say now page number 11, suppose page number 1000 में जाइए, okay, and my offset address is suppose 100. So where I have to go? I will directly go. Okay, so what I will do? So there will be a page table. Okay, page table. Now this page table convert this page number to the frame number. So what I will do? So I will go to the respective frame number and I will search for this offset address because this offset address will be same. Fine. So is it clear to all of you what we have done? So now what is given? The number of bits are given for logical address, number of bits are given for physical address, and page size is given. So from that, what we are able to calculate, now I can calculate what is the maximum memory supported for main memory, what is the maximum memory supported for secondary memory, the number of bit used for the offset address, number of bit used for the page table or pages, number of bit used for the frames. Then we have calculated total number of pages or total number of position for the pages. Similarly, we have calculated total number of frames or total number of location for the frames. So is it any doubt? Anyone have any doubt regarding this problem? You can ask me if you have any doubt. Otherwise, we will move to the next concept. So is anyone any doubt? Otherwise, copy this example. All of you note down this example. All of you note down this example. Anyone having any doubts? Say yes or no at least.
No, sir.
Okay, fine.
No, sir.
So note down this example. Then I will give one more question. Then try to solve it. Once you copy, just inform me so that I can give you the next question. Again, I'm saying there will be a more number of questions from the memory management. Okay. आपका एग्जाम में आपका मेजर क्वेश्चन the question will be something your process synchronization and memory management. Is it clear? What is your question for the examination? It will be your process synchronization and memory management. Fine. So shall we move on? All of you copied?
Yes, sir.
Okay. So let me clear this thing. Okay, that's the question. So what is given? Your secondary memory size is given, which is equal to 256 GB. Okay, 256 GB. Similarly, your main memory size is given, okay, which is your 512 KB. Then your page size is given, which is your 2 KB page size. Okay. Then your page table size is given. Okay, page table size is given. Now one extra thing is given here, which is equal to 8 KB. 8 KB. Fine. Now we have to calculate. Okay. Now calculate. That's the question. First calculate number of bits used for the logical address. Total number of bits used for the logical address. Total number of bits used for the physical address. Okay. Total number of bits used for the offset address. Okay. Then calculate the number of page. Okay. Total number of page. Total number of page of a process. Okay. Find out the number of page of a process. How many pages are required for a process? Okay. Here, total number of pages required for the process. Or you can find the number of page size. Or you can find what is the process size, total process size. What is the process size of the process? Okay. Process size kya hai? This thing you have to find. So, can anyone find the answer for me? So, let me draw the diagram for you. So, what is actually happening? So, there is my CPU. Fine. Now, CPU generate what? CPU generates a logical address. So, which is nothing but your page at object address. Okay. Then in between there is a page table which is used for a translation. Okay. The page table translate. Now this page table consists of what? Frame number. Okay. Now this particular page will be find particular frame. This are association. Okay. Now this association will give rise to a new address format, which is your frame and D. And D is nothing but this D, same offset address. Fine. And this is nothing but my what? Physical address. This is nothing but my physical address, which is associated with your main memory. Main memory. Okay. And there is one more thing which is called secondary memory. Yes. Whose size is given and the page size of the each page is how much? 2 KB. This is my 2 KB. And this total memory is 256 GB. 256 GB. And this total memory is how much? 512 KB. And this particular page table size is 8 KB. 8 KB. Yes. Now tell me, what is the number of bits for the logical address? Anyone?
So 38 bit.
It will be
38 bit.
8 bits. So, any of the answers for anyone? What's your name? इसका आंसर क्या है?
So Aditya.
Yeah, you are right, Aditya. Okay. Any और किसी का 38 आया? और किसी का 38 आया? So how to calculate logical address? Number of bit per logic. Now I have to calculate this bit. Okay. Now I have to calculate this bit. Let me name this n. So as I know that ये n क्या देता है आपका? ये n is basically refers to the secondary memory. Now, as we know, total memory, okay, secondary memory will be equal to 2 to the power of, now hold on, this is byte addressable. If I'm not mentioning anything, assume the system is byte addressable. Okay, जब तक कुछ नहीं दिया है. और secondary memory कितना आपका? Now I can know the formula. Formula क्या था आपका? Secondary memory is equal to, secondary memory is equal to 2 to the power of n into 1 byte. So what is secondary memory? 256. 256 GB. This GB. Okay, this is 2 to the power of n into 1 byte. ठीक है? Now this can be written as 2 to the power of n is equal to 256 को कैसे लिख सकते हैं? 2 to the power of 8 into, now GB can be written as 2 to the power of 30 into 1 byte divided by 1 byte. Now this goes cancel. Now 2 to the power of n equal to how much? 2 to the power of n equal to how much? 30 plus 8, which is 2 to the power 38. So n equal to how much? N equal to 38. So how many bits are used? N equal to 38. Now this, how many bits are used? How many bits are used? Now this n equal to 38. So 38 bits are used for representing the logical address. Now simply tell me how many bits are used for representing this physical. Suppose this is equal to m. M is equal to. So what is the value of m here? What is the value of m?
So 19 bit.
It will be 19.
Yes, sir. 19 bit.
Same process. Now your main memory. Okay, main memory is equal to 2 to the power of m लेना, ठीक है, और 1 byte. अब ये 512 KB हो गया और 2 to the power of m into byte. Not 2 to the power of m equal to कितना हो गया? It will be 2 to the power of something 9. Okay, और KB मतलब 2 to the power of 10 into 1 byte. समझ में आ रहा है सबको? नहीं आ रहा है? All are getting what we are doing. 2 to the power n equal to what? 2 to the power of 9. So, sorry, n. So, what is the value of n? N will be equal to 19. Fine. So, what is the value of m here? M कितना? M आ गया 9. Now, tell me, can I find now what is given? The page size is given. Page size कितना है? 2 KB. Okay. Page size कितना आता है? 2 KB. So, can I find the number of bit using D? Can I find? क्या find कर सकते हैं?
Yes, sir.
Yeah. Tell me what is the number of bits using D?
So 11.
It will be 11. Same process again. Now 2 KB will be equal to, okay, 2 KB will be equal to what? 2 to the power of, let me take D into 1 byte. Now same process fine. Now D will be equal to 11. Fine. D will be equal to 11. Now what we have find now? I can find. Now D is equal to 11. Now what is the value of F? If D equal to 11, what is the value of F? F कितना? F का value कितना यूज होगा? It will be
Sir 8.
F के लिए 8 बिट यूज होगा. सिमिलरली अगर D के लिए 11 बिट यूज हो रहा है तो P के लिए कितना बिट यूज होगा? P के लिए कितना बिट यूज होगा? Total is 38. 11 are used
Sir
for
27.
it will be 27.
Sir 27.
Now, what is the total number of pages possible? It will be 2 to the power of total number of pages. If I write total number of pages मतलब secondary memory में कितना pages हो सकते हैं, ठीक है? It will be 2 to the power of 27 and total number of frames possible, it is nothing but how much? Total number of frames possible is 2 to the power of 8. Clear? Now, still now the story is clear to all of you. Okay? Now the interesting thing, now here we are having one extra thing. We have to calculate the total size of the process. So all of you just copy this till now. अभी तक copy कर लीजिए एक बार copy कर लीजिए. So any doubts till now to anyone? Any doubt till now? How we are calculating this number of bits or how we calculate the size? Any doubt to anyone? Okay, is it copied? Is it copied? Yes. मिटा दें इसको?
Yes.
Okay.
Yes, sir.
There is only 6 minutes left. Okay, you have to again rejoin. Okay, once the time is over, rejoin again for the next session. Okay, so let me complete this topic today. So we have calculated the physical address, logical address, and value of t. Okay. So what I will do first of all, will take a screenshot. Yeah. So next, what we have to calculate? Now we have to calculate the process size. Okay. What we have to calculate? The process size. So what I already said, the process which is currently each and every process. First of all, each and every process will have its own page table. Okay. Now we have to calculate. Now this is, if suppose this is my page table. Now I have to calculate what will be the my process size. So what is given? Your page table size is given. Page table size is 8 KB. Yes or no? Page table का size कितना आपका? 8 KB है. Okay. I know that the pages are consist of frame. Now tell me. Now if the frame is using, okay, 8 bits. Frame are using how many bits? 8 bits. That means total number of frames can be of size will be 8, which is nothing but 1 byte. Yes or no? How many number of frames are possible addressing? Now 1 byte of addressing is possible. Now what will happen? Now this entire frame will be of size how many byte? Now this entire frame is addressable. Now if you address this one, the maximum size will be how much? The maximum size will be your 1 byte. Why it is 1 byte? Because we are using 8 bit. Okay, to the power of 8 bits. Okay, if it is using 8 bits for addressing, okay, so which will be maximum represent your this 8 bit. Now it can be 8 bit can be represented in 1 byte. Okay, so maximum size of each frame can be addressable is 1 byte. Now tell me, now what has happened? Now total number of location, I'm suppose I'm saying total number of locations are X. Okay, total number of frames. Now total number of frame 0, frame 1, like that, X number of frames are there. Now if I form an equation here, now what will give X into, okay, now what I multiply? Total number of frames into, this is 1 byte, this is 1 byte, that will be equal to what? That will be equal to what? Page table size. Yes or no? This will be equal to your page table size. Okay, this will be equal to your 8 KB. Fine. So I will explain why we are finding this one. Now, if we cancel this one, so it will be X is equal to what? X will be equal to 2 to the power of 3 into 2 to the power of 10 because it is KB. Now it is equal to 2 to the power of 13. Fine. 2 to the power of 13. So what is the value of X? Now how many locations are there? Total number of location is 2 to the power of 13. Okay, total number of location means total number of pages is 2 to the power of 13. Now, if the process requires, how many pages? Now, the process required how many pages? The pages is 2 to the power of 13 pages required, and each page is size of what? 2 KB. Each page of size of 2 KB. It will be 2 KB into 2 KB. Now, this will be your total process size. So, if you multiply this one, this will be 2 to the power of 13. This will be 2 to the power of 11. Yes or no? Now, if you multiply this one, it will be 2 to the power of 24. So I can write this one as 2 to the power of 2 into 2 to the power of 20. Oh, sorry, 2 to the power of 4 into 2 to the power of 20, which is nothing but 16 MB. So what is the process size here? What is the size of the process used? Size of the process used. The size of the process is used here is 16 MB. Okay, 16 MB size is used. So is it clear to all of you or not? So this page table rule, okay, this page table rule is basically used whenever they ask you to find the size of the process. How the size of process is calculated, as we know, the size of the process is nothing but number of pages is required. How to find number of pages? Now this is my X, this is number of pages. Yes or no? This is my number of pages. The page table size is given, and I know each of this of size 8-bit because we are using 8-bit for the framing. Now this all will be 8-bit. So if I form the formula क्या होगा? X into this frame size, which is 8-bit, equal to 8 KB. Fine. Now it will be something X equal to 2 to the power of 13. So what a total number of process is required? How many pages? Now, as I already said, the pages is required P0, P1 कब तक है उसको 2 to the power of 13 minus 1. We start from 0. This number, this many pages are required. And each of these pages is size is what? Page size कितना आपका? 2 KB है. Page size कितना है? 2 KB है. Okay. Then what will the total number of size of the process? So the process is total number of pages into page size. So is it clear to all of you how we can find the size of the process? Yes or no?
Yes, sir.
Is it clear how we are finding size of the process? Now this is the formula to find size of the process. Okay, size of this process. How we can find size of this process? Because as I already said, every process will have its own page table. ठीक है, हर एक प्रोसेस का अपना अपना पेज टेबल होता है और पेज टेबल हमेशा याद रखना पेज साइज से हम लोग निकालेंगे बी का वैल्यू और पेज टेबल से हमेशा हम लोग निकालेंगे किसका वैल्यू process size का वैल्यू we can find the process size even if we can calculate number of pages the process is required. Okay, the number of pages the process is required. So note down again, rejoin the class as the link will be open. Okay, just note down this problem.